like variable, such as like wood growth or type of wood. So wood growth. Yeah, you're taking similar people, separating them, giving them two different people.
I know. I just so much less.
All right.
Wednesday, January 24th. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right. Samantha's not here? Why are we late, Samantha? Stick around when the bell rings. All right, guys, you have a lab that's due today. Please go ahead and listen. If there's something on there, because I know some of you put up your observations on the same sheet. If your observations are on that sheet, so I have to look at those, put your name on that sheet, put it on top, staple everything else together. If I don't have to look at that lab sheet at all, because everything else is on a different sheet on different sheets of paper, put the lab sheet on the bottom of your lab report and put your name on the first page. Please come on up, staple them together, and turn them in. If you are not turning in your lab today, you need to come talk to me right now so I know when to expect it. Okay, come talk to me now if you're not turning it in.
So you put it on the front if we have
If he needs to see observations, yeah, you put it in front.
Sorry.
I mean, I said that.
For the hydrogen cubical sulfate, I said it looks like
put our lab numbers on
you don't have to.
pebbles.
Pebbles?
Like the.
Very rice-looking pebbles.
There we go.
And then the second page from the back.
Maria, I'm sorry. What? No, I was like, it didn't speak like, I thought you were about to go. No, and then like, I saw you. And then we're gonna kill her. I hope you don't.
I was kidding. That's an automatic statement.
If I put extra like notes on the bottom,
That's fine.
that's fine. Okay.
It says to put this one upside down. I'm like, I could have said that. I wouldn't.
I was living here.
Well, I'm away. Upside down. I'm like, wait.
It was like, wait.
Okay, so everyone's turning in a lab report. I got everyone's lab. Good enough. All right, we're going to do a little bit of a change up. And the reason for that is tomorrow there are picture days for the yearbook. If you're wondering where you are as far as your curriculars are concerned, it's up here. Wait a second. Yeah. Something's not right about that.
Yeah, where you control the variable, such as getting using the same control it. You can block in different places. You can block your subjects, right? So you block your subjects, right? Separate your subjects into different groups from similar qualities, such as runners and non-runners. Replication is much more accurate. Reproduction.
Okay, guys, go ahead and do me a favor and break out your notes. We're gonna go over the homework tomorrow.
What is the homework?
Is Oh, I don't think we finished covering all. I don't think there was.
Other than the lab? God.
Oh, yeah, it's right.
What do we do?
Wait, dude, I can't wait to learn about broccoli.
Okay, so okay, so like this is a parking spot.
Production, replication, and control group.
There's come.
No.
Take the car, go straight up through this, and then reverse it the same.
Voluntary responses, convenient responses.
Okay, listen up. So tomorrow, for instance, at 8:10, Chess Club is taking their yearbook picture. Okay, if you're involved in extracurricular, such as something like that, for instance, you're involved in band or Science Olympiad or Teen Institute, okay, the schedule for when those pictures are right is right here. Now, they're going to announce it on the announcements anyway, but I'm going to put it right here. What this means then is for those of you who are not here as we're going over the material, you'll be responsible for whatever you miss. I'm not going to stop teaching. Furthermore, they're also doing Naviance training during all of this. Yeah, so if I read this correctly, make sure I got it. Yeah, so Naviance training is also going on tomorrow, which means that when you go for Naviance, I'm not going to stop. So you're responsible for whatever you miss. Consequently, what I want to do is to try to avoid hitting all of the bigger topics. So what I'm going to do is, you may recall that you took a test for me and I haven't given it back to you yet. I've been waiting for something like this to come up. So I'm going to be passing out the test along with a key. If you're not here when we're going over the test, you'll have to come in outside of class if you want to look at your test and look at the key and if you have any questions, okay? It's just the easiest way. The homework that we still have to go over, we're going to go over it during that time as well. So if you're not here when we're going over the homework, you need to get in contact with a classmate to find out what you missed. If you miss any of the new information, that's regrettable. But you'll just have to get the notes and get caught up as best we can. But I'm trying to limit how much of the new material you guys are going to miss. So what you're going to be missing is old material as we go over the homework and the older test. Do you guys understand? Okay, so with notes out, we're ready to go ahead and we're going to push forward into the chapter. One of the things that we had looked at so far in terms of quantum theory was Planck and Einstein's contribution to quantum theory, which deals with energy or electromagnetic radiation. The fact that it can be wave-like in nature, certainly, but other times it behaves as if it was particles. And again, of course, now today we know that it's always particle-like in nature. It might behave as a wave, but it's truly, literally particles. Well, a guy named Louis de Broglie, or de Broglie, depends on how you want to pronounce his name. De Broglie said that, wait a second. You're saying to me that light, which we've always thought of as being wave-like in nature, talk about rainbows and refraction, it's clearly wave behavior. You're saying it can now be particle-like in nature, Einstein? Well, if that, and you're also saying E equals mc squared, you're saying matter and energy are just different forms of the same thing? Well then, if that's true, if matter and energy are just different forms of the same thing, and if energy can have this particle-like property associated with it as long as the wavelength, then what's good for the goose is good for the gander. You heard that expression before? No? In other words, if it's good for one, it's good for the other. If it's good for EMR or energy, then I think that matter, which we always think of as being particle-like in nature. You think of molecules and atoms and protons and electrons. Clearly matter is particle-like in nature. Then I think matter in motion could be wave-like in nature at other times. And he set about trying to go ahead and see if he could verify that. He used E equals mc squared. He knew about that. He knew E equals h nu from the work there. And of course, he knows about C equals lambda times nu. Now, Einstein's theory of relativity already specified that it is impossible for anything to travel at the speed of light. That is, there's no matter that can travel that fast. You can approach it, but you can't actually equal it. So rather than speed of light, if we replace this with the velocity of matter, and then employ some rather sophisticated mathematical manipulation known as Algebra 1, okay, through substitution and derivation, okay, so an Algebra 1 student could do this. He was able to take these three equations using substitution and setting equations equal to each other, came up with lambda is equal to h over mv. If you want to like dally a little bit with your Algebra 1 skills, you can see if you can take those three equations and come up with the same conclusion that de Broglie did. And this is known as de Broglie's equation, and he is responsible for what is known as the concept or the theory of the duality of matter. The duality, dual means two, right? So the duality of matter meaning that matter in motion up here, oh, by the way, m times v is what we call momentum. Okay. Things that have more momentum are harder to get to change in terms of the direction they're going. Okay, so it's a lot harder to stop a train than a tricycle going at the same speed. It's a lot harder to stop a tricycle going at 20 miles per hour than it is at going 2 miles per hour. And it has more momentum. What he said was this, is that this equation shows that matter in motion can be wave-like in nature. There's our wavelength. But at other times, it can be particle-like in nature because momentum is a condition of a particle. You on the same wavelength as somebody else? You could be, because according to de Broglie, you could be behaving as a wave. You can have wave-like properties. Yes?
How does just rearranging the equations like mean that it definitely can be both?
It doesn't mean it can be both at the same time. He's not saying at the same time. He's saying that it could be wave-like in nature at a different time. And the idea being is that we always know that momentum is clearly a condition of particles, of matter. Okay, so a wave can't have momentum. Okay, particles have momentum. But particles don't have wavelength. So what we're saying here is matter can be particle-like in times, and at other times it can be wave-like. Just like when we said before, energy can be wave-like in nature, but at other times, because a photon is a particle, at other times it can be particle-like in nature. Now, as it so happens, you'll notice that Planck's constant is part of this equation. Planck's constant in our universe is exceedingly small, 10 to the negative 34th in terms of magnitude. Consequently, guys, you are not going to see the wave-like nature of matter being manifested by anything that is of size, that you can see with your eye. The only thing that's going to actually be able to show observable wave-like nature would be extremely small particles moving very rapidly. We're talking about things like electrons, which is kind of good, because if it were otherwise, that would mean that, well, I think you all would agree that if you saw me walk through this doorway and all of a sudden you saw me go, and saw Mr.Sawan's, okay, as I was being diffracted, passing through this narrow opening, that would be a little disconcerting. In fact, someone sort of joked and made a comic out of it. Let's see if we can find it. Come on, there it is. Yes. So another view of Mr. Tompkins' Wonderland in which Planck's constant is much larger than in our world. The caption read, "Sir Richard was ready to shoot when the professor stopped him. The professor went on to explain, there is very little chance of hitting an animal when it's moving in a diffraction pattern." And you can see the hunters here and the little antelope coming through the trees and being diffracted. Okay, because that's what sort of our world would be like. You'd end up with animals being diffracted as they're passing through narrow openings such as trees. Now, I should point out, there's a diffraction, as the little guy comes through, he's being diffracted. And it is Mr. Swan's coming through the doorway, a little disconcerting. I have to point out that this is all mathematical and theoretically based. Okay, there isn't a shred of evidence to support this.